So in trying to conduct what we're saying over here, a two-factor analysis over here, we can be able to see that the covariance C and D, so solution, right over here. So covariance CD is given as follows, ladies and gentlemen. So we are getting the beta for market C, using factor 1. Then we multiply that by the beta of market D for first factor times the variance based on factor 1. Then to that we add the beta for the beta for market C, second factor. This is the second factor, this is the first factor. First factor, first factor, first factor. So we do the same, but now for the second factor. That. Then we multiply that with beta for market D, second factor. Then we can be able to now do or conduct the variance of factor 2, like that. Plus, ladies and gentlemen, plus we have beta for C market 1, beta for market D, factor 2, plus beta C for the second factor. So we've done first factor, second factor. So we are going to do second factor, first factor, like that. So beta for C for the second factor, and then we multiply beta for D for the first factor right over there. We close the bracket because we've opened the bracket right over there, and we continue and say covariance, F1, F2. I hope you've understood what we're doing. We're trying to get the covariance of market C and D. So for us to get the covariance, we are going to get, first of all, the beta for market C, the first factor, beta for market D, the first factor, variance for factor 1. Then we get the beta for market C, factor 2, beta for market D, factor 2, for market D, factor 2, and then the variance, factor 2, like that. And then we just multiply it by this component over here, the beta or the factor sensitivities for market 1, factor sensitivities for market 2 over there under factor 2, the factor sensitivities for market C under factor 2, factor sensitivities for market D under market D factor 1, then times covariance factor 1 and factor 2 there. So putting it all together, if you allow me, I can come on this other side, ladies and gentlemen. I can come here. We are saying what? So the specifics in terms of the value. So covariance CD is given as, we're just repeating what we've just written over here, but now putting the values there. So we are putting it 0.9 multiplied by 0.8 multiplied by 0.0211 plus. So that's the first component over here. That component there. Another component there. And then there's that component there. That's the first component. And then we have 0 multiplied by 0 and multiplied by, ladies and gentlemen, 0.000019, like that. That's the second component there. And then we are adding what? Now we are adding this part over here, like that. So we are adding 0.9 times 0, that part there, plus 0 times 0.8, like that. And then we multiply by the covariance of factor 1 and factor 2. Covariance of factor 1 and factor 2 from the table is given to us there, I can see as 0.0015. So how much do we get for this over here? Pick my calculator very fast. Here, work it out. At 0.9 times 0.8 times 0.22, 0.211 plus that, 0, that's 0 plus plus that 0.11 there. I'm getting 0.0152. 0.0152. That is the covariance of market C and D. Once we've gotten that, then we can proceed on to also estimate the variance for market C. How do we estimate the variance for market C? So variance for market C over there, and how we estimate the variance is given as the following formula over here. Variance is given as beta squared C market 1, then we multiply by the variance of factor 1 plus we get beta squared of C2 multiplied by variance, or variance over there of factor 2, that plus 2 beta of C1 beta of D of C2, sorry, C2, C1, C2, beta of C1, C2, and then covariance F1, F2 over there, plus what we are saying, the variance of the error term, market C. So we're dealing with market C, ladies and gentlemen. That's why we're saying we're just doing C, 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 like that. How about for D? We'll do the same, but now we'll be able to do with the values for D. Putting it all together, you can have the values as follows over here. So variance squared is equals to, deviation squared is given as, we are having 0.9 squared multiplied by 0.211, 0.211, because we're saying that this is the variance, ladies and gentlemen. This is the variance. So it's 0.0211 there, like that. And then we are adding, we have 0 squared multiplied by 0.0019, close the bracket over there. So we're multiplying that, like that, sorry. So 0 times that value there. And then we are saying we have 2, we are at this part over here, 2, this part over here, beta C1, beta C2, covariance F1, F2 plus that value there. So 2 multiplied by 0.9 multiplied by 0 multiplied by 0.0015 over there. So how much do we get for the variance for this market here? So working it out very quickly, so I have over here, so I'm getting, ladies and gentlemen, 0.0171. That is the variance over there. But what about standard deviation? So you get standard deviation is given as 0.0171. You get the square root of that. That's what we get over there. So if you get the square root, so square root of 0.0171, we get a standard deviation of 0.13. How about variance for market D? We use the same formula, but I'm just going to now indicate, so standard deviation squared is given as beta squared for D1, standard deviation squared of factor 1, then plus beta squared of D2, factor 2, variance squared of factor 2. We're saying we have factor 2, yes, factor 2 like that. And then plus, now we are repeating the part that has got that constant 2 there. So 2 beta D1 beta D2 covariance F1, F2 plus standard deviation, error term there. So putting it all together, how much do we have? So we have 0.8 squared, 0.8 squared multiplied by the variance, 0.0211 there, then plus we have 0 squared there, then multiplied by, of course here there's multiplication by 0.019 plus 2 times 0.8 multiplied by 0.0015 over there. So how much do we get for this value here? So very quickly, just work it out. So I'm getting 0.0135. 0.0135 like that. And having computed the variance for market C, variance for market D, we are saying that the variance for the markets will tend to be higher.